Dear viewers, welcome to Vedavyasa Academy. I am Srinivas, Maths Trainer. Now I am presenting before you Concepts of Coordinate Geometry, Part 2. Part 1 completed. In that Part 1, we discussed what is coordinate geometry and distance between 2 points, section formula. Like this, we completed in part 1 and also we completed in part 1, that is centroid of the triangle and in center of the triangle. Once again, we briefly discuss centroid, in center and continuous. You see all of you. Here, this is the triangle ABC. This is A, B, C. This is the angle A and this is angle B. This is angle C. Here, these are the angles. This is vertex A. Opposite to vertex A side is A. Opposite to vertex B side is B. Opposite to vertex C side is small c. These are the sides, represented sides. Okay, all of you? Here, once again, if vertex A x1 y1 coordinates, vertex B x2 y2 coordinates, vertex C x3 y3 coordinates are there. Then what is the centroid of the triangle? We know that what is the centroid of the triangle? Medians of a sides are concurrent. Medians of a sides are concurrent. Then concurrency point is called centroid of the triangle. Medians of sides of triangle are concurrent. Concurrency point is centroid, represented by or denoted by G. So what is G? G is equal to x1 plus x2 plus x3 by 3. y1 plus y2 plus y3 by 3. This is the centroid of the triangle. Okay, this is the centroid of the triangle. So, we discuss later what is in center. Centroid completed. In center. How to calculate in center? What is in center? In center means angle bisectors of a triangle are concurrent. Angle bisectors of a triangle are concurrent. Then concurrency point is in center. Then concurrency point is in center. Okay, all of you? In center represented by I. I is equal to AX1 plus BY1 BX2 plus CX3 by A plus B plus C. AY1 plus BY2 plus CY3 by A plus B plus C is the in center of the triangle. How to find? This is the angle bisector. and this is the one angle bisector. This is the one angle bisector. This is the incenter of the triangle. This is the incircle. With incenter, we draw the incircle of the triangle. This is the main advantage in coordinate geometry. Okay, all of you. So this is the incenter. This is the radius of the incenter, smaller. Radius of the incenter, smaller. Okay, all of you. What is incenter? Angle bisectors of a triangle. Angle bisectors of a triangle are concurrent. Then concurrency point is called a incenter of the triangle. Okay, incenter of, if the coordinates of A, B, C are given in coordinate geometry, then we can find incenter. How to find incenter? I is equal to ax1 plus bx2 plus cx3 by a plus b plus c comma ay1 plus by2 plus cy3 by a plus b plus c. We have to find the incenter of the triangle like this. So this is the incenter of the triangle. Okay, all of you. What is x center? X center. How to calculate x center of the triangle? What is x center of the triangle? You see, all of you, here this is the triangle ABC. A, B, C. Here A coordinates x1 comma y1, B coordinates x2 comma y2, C coordinates x3 comma y3. You write this is C, x3 comma y3, and this is B and x2 comma y2. What is x center? Suppose we draw the angle bisector from A like this. You extend, okay, and you extend these B to here and you extend C to here. This where C you draw the external angle bisector like this. Here you draw the external angle bisector like this. These are intersect or these are concurrent here. This is I1. And from I1 you draw X circle opposite to the vertex A. X circle opposite to the vertex A. Like this. This is the X center of the triangle opposite to the vertex A, and it is represented by I1. And the radius of this X circle is R1. Radius of this X circle is R1. So, what is X center? Internal bisector of vertex A and external bisector of vertex B and C is called a X center opposite to the vertex A and is represented by I1, and radius of this X circle is represented by R1. Okay, all of you. Here X center opposite vertex A. Okay, this is internal bisector. Internal bisector, angle bisector. Angle bisector of A and external angle bisectors of B and C. B and C are concurrent. Concurrency point is X center, represented by or denoted by denoted by I1, and circle radius is R1. Okay, I1, R1. Then what is the coordinates of I1? Here, coordinates of I1 is, this is, coordinates of I1 is, this is minus coordinates of I1 ax1 plus bx2 plus cx3 by minus a plus b plus c minus ay1 plus by2 plus cy3 by minus a plus b plus c. These are the coordinates of the external bisector, external x circle opposite to the vertex, x center opposite to the vertex A, opposite to the vertex A. Okay, all of you, that's all. Now, x center opposite to the vertex B is, you draw this like this. Okay, this is the inside angle bisector of B, and this is the external angle bisector of C. This is the external angle bisector of A, and this is I2. Coordinates of I2 is equal to, this is ax1 minus bx2 plus cx3 by a minus b plus c, and ay1 minus by2 plus cy3 by a minus b plus c, and radius is equal to r2. Radius is equal to r2. Similarly, similarly, in center opposite to vertex C is in circle, in centers. This is I3 is equal to, this is ax1 plus bx2 minus cx3 by a plus b minus c, comma ay1 plus by2 minus cy3 by a plus b minus c. These are the incenters, and the radius of I3 is R3. Okay, x centers in center. This is x center in circle, x circle opposite to the vertex A, x circle opposite to the vertex B, x circle opposite to the vertex A, and these are the x circles, and in center centroid completed. Next we go for orthocenter. Orthocenter represented by O. Orthocenter represented by O. Here you see, this is the vertex A. This is the altitude from vertex A to the opposite side, AD. Altitude AD, and this is the altitude vertex C to this opposite side AB. This is the altitude from B to opposite side A, C is E, F. Altitude AD, altitude BE, altitude CF. What is altitude? Altitude means line draw from vertex 2 opposite side in a triangle is altitude. Altitude of a side. Okay, all of you. So here these are the altitude. One altitude draw from A to the opposite side BC. One altitude draw from B vertex B to the opposite side AC, and one altitude draw from vertex C to the opposite side AB. Here AD, BE, CFR altitudes are concurrent at O. At O, this O is orthocenter. Orthocenter. O is orthocenter. Okay, here in a triangle, altitudes are concurrent. This concurrency point is called a what is orthocenter. So this is the altitude and altitude of a triangle. Altitudes of a triangle are concurrent and concurrency point is called a orthocenter. This is the orthocenter of a triangle. We discuss problems on this orthocenter analytically in problems. Okay, whenever we can do problems, we can find orthocenter in there. In problems exercise, we can find the orthocenter of a triangle. Okay, all of you. Next, we go for here. Now we discuss about the circumcenter of the triangle. How to find the circumcenter? Circumcenter means triangle is inside and outside the circle. That is the circumcenter. Angle bisectors. Angle bisectors. Sorry. Here perpendicular bisectors. Perpendicular bisectors of a triangle are concurrent. This is the one of the perpendicular bisector. This is the perpendicular bisectors of a triangle. Perpendicular bisectors of a triangle are concurrent. This is the perpendicular bisectors are concurrent, and concurrency point is called a circumcircle. Concurrency point is called a circumcenter and is represented by S, and this radius is capital R. Radius represented by capital R and center represented by S. So this is the perpendicular bisectors of a sides are concurrent, and concurrency point is called a circumcenter of a triangle. Circumcenter of a triangle is represented by S, and circumradius is represented by capital R. Okay, all of you. That's all.